Hi, I'm Nina Lanza. I'm a postdoc on the ChemCam instrument, and this is your Curiosity rover update. This has been a very exciting week for the Curiosity rover. It delivered its third sample to Chimera to complete its cleaning regimen, and also we've done our first chem-in analysis, and we've got a second one on the way. In its spare time, Curiosity has also been making measurements with other instruments, including the ChemCam instrument, which is what I work on. ChemCam is actually two instruments in one. It includes a camera with a telephoto lens, and it also has a laser that vaporizes a very small amount of rock so that we can tell what its chemical composition is. And as of this week, we will have done 10,000 shots with the ChemCam laser. This week, we've been analyzing rocks in an area called Rock Nest, and I'll tell you in particular about one called Zephyr. This one is interesting because it appears to be made of two different types of materials. It's got this harder, more resistant material on the top, capping it, and then beneath that it has a lighter colored, softer material that appears to erode more easily. It's actually eroded into a set of natural arches, so some of our team members have taken to calling it Stonehenge. This feature is really only an inch long. We're shooting this from about 8 feet away, making the pointing very difficult. So that's why we decided to do 9 points instead of just 2, just to make sure we would hit the material of interest. We ended up hitting both the dark and the light material, and we found that there was indeed a compositional difference. In addition to composition, we've also been able to make a three-dimensional model of the surface of this target using images from the remote microimager part of ChemCam. We've also used ChemCam to measure soils, such as cristarum. Here you can see a before image and then after image where you can see the crater made by the laser. This week, ChemCam did its very first depth profile, in which we shot the laser 600 times in a single location in order to tunnel through the surface of the rock. Now, this only tunnels about 1 millimeter in depth, but it can help us understand how the composition of the sample changes from the surface to the interior. Coming up, we'll be able to use this information that we've learned from ChemCam in order to decide which targets we should hit next with other instruments. This has been your Curiosity rover report. Please check back for more updates.